In this video, we are going to describe two transformations of the graph of a function. In each of the following, the graph of y equal f of x undergoes two transformations to become the graph of y equal g of x. We have to describe the two transformations. Part A, g of x equals f of x minus 2 and then plus 4. The first transformation is this minus 2 inside the brackets, and the second transformation is this plus 4 outside the brackets. Before we continue, can you tell which types of transformations they are? Translation, reflection, or enlargement or reduction? Remember this, when only addition or subtraction is involved, the type of transformation will always be translation. So that involves two translations for this graph of function. And it's easy to see the magnitudes of the translations. The first one is by 2 units and the second one is by 4 units. Then the hard part, the direction. The first transformation involves addition or subtraction inside the brackets, so it's about changing the x-coordinates of the points on the graph, and thus the resultant graph will be shifting left or right. Comparing f of x and f of x minus 2. In the original function f, if we put a for x, y will be equal to f of a, that's obvious. Then for the function f of x minus 2, if we put a plus 2 for x, y will be equal to f of a plus 2 minus 2. That is also f of a, the same as the original function. From this, we know that every point on the graph of y equal f of x minus 2 will have an x-coordinate that is 2 greater than the original, while the point's y-coordinate remains unchanged. This results in a shift of the graph to the right. We say that the graph of the function is translated to the right by 2 units. And the second transformation involves addition or subtraction outside the brackets. So it's about changing the y-coordinates of the points on the graph, and thus the resulting graph will be shifting up or down. It's more straightforward. It's simply adding the value of 4 to the y-coordinate of every point on the graph, so the graph will be shifting upwards. We say that the graph of the function is translated upwards by 4 units. To describe these two transformations in a complete sentence, it would be: the graph of y equal f of x is translated to the right by 2 units, and then the resulting graph is translated upwards by 4 units to become the graph of y equal g of x. Part B, g of x is equal to f of 3x minus 1. The first transformation is this 3 inside the brackets, and the second transformation is this minus 1 outside the brackets. Again, can you tell which kind of transformations they are? Translation, reflection, or enlargement or reduction? As mentioned in part A, the second transformation involves subtraction, so it's going to be a translation. How about the first transformation, f of 3 times x, a multiplication? When there's a multiplication or division, we know it's going to be an enlargement or a reduction unless we are multiplying a negative 1 to it, in which case it would be a reflection. So this time it's only an enlargement or a reduction. And the 3 is inside the brackets, affecting the x-coordinates, so it's enlargement or reduction along the x-axis but not the y-axis. If we put a for x into the original function f, we get y equal f of a. And if we put 1/3 of a for x into f of 3x, y will be equal to f of 3 times 1/3 of a, which is also f of a. That means for every point on the graph of y equal f of 3x, the x-coordinate will be 1/3 of the original, whilst the y-coordinate remains unchanged. As a result, the graph is reduced to 1/3 of the original along the x-axis. Using a sine function to demonstrate this, it will look like this. and then the minus 1. We are subtracting 1 from the function, so the y-coordinate of every point on the graph is 1 less than the original. So the graph is shifting downwards. We say that the graph of the function is translated downwards by 1 unit. Let's put them together in a full sentence. The graph of y equal f of x is reduced to 1/3 of the original along the x-axis, and then the resulting graph is translated downwards by 1 unit to become the graph of y equal g of x. You can see that when we describe a transformation, there are always 3 parts: the type of transformation, the direction, and the magnitude. Except reflection. Reflection doesn't have the magnitude part. You may check if you miss any. That's it.